multiplayer crafting survival game in Unity 3D and TypeScript. I've been working on the pathfinding for my first aggressive mob, which is the troll. And in the last stream, I did my first cut of my A-star implementation. When I ran it, it returned an empty path, and I put a little bit of effort into debugging that. It turned out to be a bug in the way I was building the graph. But with that fixed, it is now returning a path. So today I'm going to continue working on that algorithm just to make sure that it's working. The current implementation is only designed to work within a single chunk, and so I need to work on loading additional graph pieces for the other chunks that the origin is not in, and kind of dynamically generate those bits of graph and stitch them up to the existing graph. I'll be renaming the vertices and edges within that graph because that's causing a lot of confusion. Certainly when I'm explaining things, I use the word vertex to mean both a triangle, a cell within the nav mesh, and also within a point within the mesh. And of course, I need to validate the results that are coming out of A star. I'm highly suspicious of them. Something doesn't quite look right when I run the troll. And what else have I got? I need to validate the graph build. I've noticed something strange, and once I've validated the most basic of results coming out of A star, I'll then move on to validating the graph build. Okay, we should be live on both Twitch and YouTube. It appears that's the case. I'm just going to confirm that. And yes, that looks pretty good. Excellent. So, I'm going to start by validating the results of A star. I can find my development window, and I'll do this with a unit test is the first way I'm going to do this, just to get rid of any silly mistakes. Make sure that I am sending through the endpoints in the path, because if I don't do that, then the troll motion won't make any sense at all. Sorry, I need to reconfigure some windows over here. There we go. Now, the A star is currently done by the terrain service, so I'll add a test in here. And this is going to start by passing a really simple graph through, just with two vertices and a single edge between those vertices. And we should be able to get a search working that just goes from that origin to that destination. Well, in fact, let's start simpler than that, and let's do test within a single cell. Search a single cell. Okay. All right. So I probably want this paths controller because the method I want to test is this method here. Now it's not currently exported; it's not required to be exported. So a little pattern that can be useful is to just export the const um, export for test, and in here. My apologies, we can just test this method. That makes perfect sense. Just to test the path controller, generate path. Okay. I will have to mock out the graph builder, but that's easy to do. So I'll search for a point, just left of the origin to just right of the origin. What doesn't it like here? I'm missing a brace. Okay. Now, I expect if I call, I can't remember how to write, it's been a simple test. My mind's gone blank. Expect path.points, and I want it to equal a list that, because these are within the one cell, I expect the path to be literally new vector 3. Let's make some constants for the origin and the destination. It's going to be the same thing but positive. I don't think I even need to mock the destination out, the graph out in this test case, because in a standard graph, as long as I give it a dummy chunk, it should these should exist within a single cell within a non-mocked graph anyway. So I expect it to return an origin and a destination. Now, since I'm not sending in any dummy data, this will fail because we'll actually get some height data back. But let's just give this test a go, just see if it even remotely works. Yeah, that's just normal IntelliJ not finding my imports properly. Okay, this looks kind of promising. It has modified my X coordinates and Z coordinates. And the issue here is that this is probably searching between between cells, and the issue here is that out to the left of the origin is in one triangle, and out to the right will indeed be in another triangle. So I actually want to go a really short distance here. I believe they will be in the same triangle, and now the test will fail for a different reason, which is there is actually a bug that we're not inserting these endpoints into our path. And we can see here that we're getting back an empty array because these are in the same cell, but that is not what I want. So I'm going to have to go and change the controller to make sure that this result, wherever it is, where is it? Find shortest path. This currently grabs all the states that came out of the search, reverses them as expected, but we do need to insert the origin and the destination in here. So I'm glad I wrote that test. Origin, destination. There we go. So this test, I reckon, will now pass if once my stuff compiles. Compute points portals, what's wrong with that? Yes. I've just broken something in here. So this is a vector 3. I can't do this here. This is expected to return a list of portals. For anyone who's not, who's just joined and wasn't here for yesterday's stream, I will describe portals again in just a moment because it's a concept that we're going to need for another phase of this algorithm. So it's really compute points, I guess. This needs to know the origin. It needs to know the portals and it needs to know the destination. This should work better. Origin, destination. Still doesn't compile because I'm not passing through the origin and the destination. So that's options.origin, options.destination. There we go. Rerunning my test. And that works. Awesome. So next, I need to write another test. Let's do a search between two cells. Now, I really don't want to rely on this now because on the fact that the graph is being built by the search, because it's going to be too hard to choose 2 points that I know are definitely within different cells with no other cells between them. So let's just copy and paste this code. This time, because I'm going to be building the graph, I can put the cells wherever I like. I need to mock out the graph builder. Again, I can't remember how to do a mock, so I will copy and paste some other code I have that I've probably copied and pasted from somewhere else. And this time, what do I need to mock out? It's find shortest path, get shortest path state that is responsible for, no, this gets past the graph. So I need to make sure that the graph that's passed in here is mocked out. So build chunk graph. Easy. So let's mock that out. This is in what file are we in? The path controller. So let's mock out path controller. In general, we're going to just use whatever its actual implementation is. And then we're going to replace that with build chunk graph. We're going to mock the implementation. Now I'm just going to take a look at what this code was doing. It was the chunk index. The get method build chunk graph is just going to be a function. And all we want to do here is return one of these. So a list of vertices and a list of edges. So let's see, const vertices. Not a mesh vertex, that is one of these ones. Where are these? I'm going to have to do a bunch of exports here. I don't like exporting stuff that I don't need, but it's just going to be easier for testing. Where's the graph builder? Build graph, build chunk graph. It needs to be exported as well so that I can mock it. From the path controller. Hello, Loxlolex, and welcome back to the stream. So I got A star working in the last stream, and well, kind of working. It after I got A star working after the last stream, and it was with a few limitations. It only works within a single chunk at the moment, and I'm currently just testing the results just to make sure that everything makes sense. I've already found one bug, and I suspect I'm going to find some more before I get started on getting it working between multiple chunks. Okay. Vertices. So I need to give it 2 cells. Think of this as being the cells. Now in here I need we want 2 of them. Okay, just thinking out loud here. I mean, I really want to mock this down in the individual test because obviously if I've got different tests, then I want it to return different things from in here. I'll worry about that in a moment. Everything's going very well, thanks, Luxlolex. Vertex. So I need a coordinate. Let's just give it a coordinate. This is the center point. Oh no, this is the proper coordinate. I don't really care what this is. Let's just, do we have a coordinate .0? Yes. So we don't really use this within the algorithm. This is just for, I suspect those coordinates will actually go away. Or we might use them for looking up data later. Now I do need a position. This is just the center point of the cell. So in this case, let's do a vector 3, which is just off to the left of the origin. So -1, 0, 0. And a second vertex with whatever coordinate and just off to the right of the that seem fair? What's wrong with that? A new vertex should be returning the correct type. Edges are allowed to be undefined. Oh, that's not a vertex. It's meant to be a vertex array. Okay. So next, the edges. Let's create a new edge. This comes from vertices 0. The second one comes from vertex 1. Then down in here, I need to configure those edges. So that's going to be edges 0. This is the one coming from vertex 0, dot 2. And then what do I need to pass through in there? Here's my 2 setter. I need to give it a vertex that it goes to and a portal that it's going to pass through. So, sorry, what's that? The vertex that it goes to is going to be vertices 1. The portal is a pair of vectors. So I'll make this a vertical line. New vector 3, so that it's orthogonal to the, it's perpendicular to the center points of the 2 cells. This is going to be 0, 1, 0. New vector 3, 0, minus 1, 0. Repeat that. This is very verbose code. Now this one is going to loop back to number 0, but have that exact same portal. Awesome. All right. Now I can pull this out into a separate constant. So let's make this actually just return mocked graph. Let's define that graph up here. Mocked graph is going to be equal to, and this just needs vertices, which is a vertex no, let's make that an empty list. Edges is an empty list. This is of type vertices, vertex, array, and edges. I really need to define types for these, don't I? Edges is an edge array. And then down in my actual test, before I start testing, I can go and change this to be mocked graph dot vertices is going to be equal to that. All right, I think this will work. Then good old IntelliJ letting me type in multiple places at once. Okay, so when we do the test, we configure this mocked graph object. This has already been set up so that anytime someone calls build graph chunk, it just returns whatever this object is. We then ask it to do a search from -1 to +1. This is literally searching from the center point of one of the cells to the center point of the other. We expect it to pass through here. So I do expect this to have a second vertex in here, a third vertex in between those two. Let's just run that test first, make sure that it does something slightly sensible. Run that. Expecting it to fail. It looks close. I'm pretty sure this is saying that it did return that edge, that point. It did return that point. But it looks like it's returned 2 points in between, which is a little surprising. I might debug that. I'm going to throw a breakpoint in the code that processes the states. Point get shortest path state, and then we process those states just in here. So we'll come back, we'll come to here, right click, debug. Okay, so what are our states? What am I expecting our states to be? I expect to get a state when it reaches the destination cell. I expect there to be a state for the origin, which is the root state. So I expect two states in this chain in target state. So target state is just some state. It has a parent, and that itself also has a parent. So I believe I have too many states here, which is a bit of a worry. So what I'm going to do is I'm going to come back into here and just confirm that I do indeed have my graph being correctly defined. So let's rerun that. I'd say that what I'm actually getting here is yeah, I'd say that it's actually building the graph when it's not meant to be. Come on, why are you not building? Oh, am I just in the wrong tab? Oh, it's running some other test that I've probably not maintained. All right. Debug that one. Here we go. So what does my graph look like? It has thousands of vertices and edges. So this has gone off and built its own graph. That's a bit of a pain. Now, most likely that's because I'm trying to mock out something that this depends on. But this is probably calling the method directly. So when we call into find shortest path, where do we do the actual graph build? Yeah, sorry, in here, when this tries to build the chunk graph, I'd say this is calling the actual implementation, whereas I want it to be calling the implementation. So I might actually put an extra parameter on here. I'll put it in a constructor. And we'll pass through a parameter here called graph builder. Now this is going to be something that returns, sorry, this is going to be a function that takes nothing, but returns a list of vertices and a list of edges. And by default, this is going to be equal to build chunk graph. Why doesn't it like that? Oh, that's probably fair enough. Let's build chunk graph. This takes a mesh. All right. So this needs to take a mesh and returns a graph. I'll turn that into a type shortly, and it defaults to our own implementation. Now down in here, we will do this dot graph builder. Oops, private graph builder is, I really need to get these types defined. I keep on saying that. I should actually just bite the bullet, shouldn't I? But I won't. This dot graph builder is going to be equal to graph builder. Okay, so now we can configure this over here. What doesn't it like here? My field can be read only. Fair enough. We'll do that. So if we don't configure a graph builder, we get the default implementation. But if I go into my test, I can pass in here the mocked graph builder. Now, that is... what's it going to be called? I think I need to import this module, but if I do build chunk graph down in here, I think that will now use the mocked one. All right, let's give that a go. Spin it up in the debugger. And now I have a graph that contains 2 vertices and 2 edges. Perfect. Let this run through. Go to the debugger. Edges is not iterable. That's not what I was hoping for. This is because when I initialize this graph, these vertices, I'm not putting any edges on them. So I'm going to have to do mocked graph dot vertices 0 dot edges. Let's just pass it that edge. We'll pass it a new edge that goes nowhere, because it is expecting 3 graphs per vertex, through 3 edges per vertex. So we'll create a new edge coming from there that doesn't go anywhere. And again, another one of those. Oops. Oh, what am I doing here? There we go. Then likewise, this is just getting this graph all stitched up. This needs to be a 1. This needs to be a 1, and this needs to be a 1. All right, is that going to work? Run the test. And it fails, but this time it's because I've not actually finished the test. So it correctly returned the center point of the portal in here. Now, I'm going to put a new vector 3, 0, 0, 0 in here. Which we know is going to be true for my dodgy string pull algorithm. So my dodgy string pull algorithm at the moment is just taking the center point of the portals. But even once we do a string pull, we expect this to be going to the midpoint of origin and destination. So this is returning a straight line path, but I do indeed want this potential inflection point in the path. So even once we get the string pull working, I believe this is valid. So run the test again. This we know will pass. Oh, unless I've got some weird equality problem. No, there we go. All right. I think that that's looking pretty good. I know it's only a simple validation, but it at least shows that we can move from cell to cell. We can search within cells, and I'm pretty happy with that. I'll validate the graph in a moment. Next, I'm going to rename the vertex and edge types. This has been annoying me like nothing else. So this I am going to call a cell, I think is a better name. So our graph, instead of being made up of vertices, is now going to be made up of cells. And instead of edge, I guess we could actually just rename this to portal. So a portal is what links from one cell to another. We probably want to rename this to I'm just going to call this gateway. So this is the gateway for the portal. It's the actual location that you can pass through. 2. And I'll need to rename these. Needs to be a gateway. That one needs to be a gateway. This needs to be a cell. And this, oops, needs to be cell. Almost done on this rename. Let's get a bit more screen real estate there. There we go. So inside a cell, we have a coordinate. This one should be called center. Yes. Instead of edges, I want portals. That should be center. Got portals. Excellent. Now, last thing I want to do here is change the is define this as a proper type. Can I factor this out? Will IntelliJ do this for me? Can I do refactor? Extract interface. Place all 3 occurrences. Yes, it can. Awesome. I really like IntelliJ. Now this, I kind of want to call it a graph, but this is actually only a chunk, the graph for a single chunk. So I'm going to call it graph chunk. Because these, oh, what was that? Oh, I pressed the wrong button somewhere in there. Extract the interface for all 3 occurrences. Graph chunk. So what we will be doing is getting a bunch of these graph chunks and stitching them together very shortly. Okay, so I have done the rename. Validate the graph build. So first of all, I will show what my issue is here. So if I spin up the actual server and get a breakpoint just after we do the graph build, here we go. If I breakpoint in here, something has crashed. Oh, is this not compiling? That is wrong. What's that? .2 dot, we called this the gateway. Perfect. Spin that up. That seems to be running. Shell somewhere in here. That's posting a troll. Where's an example of a path? All right, here I am trying to find a path. When I hit this breakpoint and take a look at my graph, vertices at the beginning refer to cells within the origin voxel. And you can see that in here. This one has a coordinate of 0, 0, 0, 0, which is right at the center of a chunk. But if we look at its portals, I was going to complain that these were, one of these portals was linking off to nowhere. But I think that I probably was looking at something that was in an invalid state, because these all look good. But what I can do, I'll still write a test that goes and calls out to the graph builder. So let's test graph builder returns fully connected mesh. So what I'm trying to do here is just make sure that when you build a graph for a chunk, every single cell should connect to 3 other cells except for cells that are right on the edge of the chunk, and they won't. They need to be connected later. They'll get stitched up once we load other chunks. So we're going to build a chunk graph. I need to give it a mesh, which needs vertices. And it needs... Oh, well, I guess I actually want to load a chunk. What's the best way of doing that? Terrain controller, probably. No, not terrain client. Do I not have terrain controller? Oh, chunk controller it's called, isn't it? No, going insane. Oh, chunks controller. I'm not being consistent about my plurals. Nope. Ah, what am I doing here? All right. It doesn't like that. I'm not exporting that later. Get chunk. I need to give it a coordinate, which is just the chunk coordinate. And in fact, I can pass that directly into the builder. So this is going to build a legitimate graph. Chunk. What do we normally pass into this method? We normally call get mesh on the chunk. Get mesh. This also needs to know the coordinate, I presume. Still not there. Oh, yep, fair enough. I'm not having much luck here. Bear with me. Okay, there we go. So this will actually generate a legitimate chunk with all the height map data and stuff. We don't need this to be a BOK in any way because we're not doing anything too complicated here. Where they're going to generate a mesh for it, which returns all of the 3D vertices and edges. I can now use that term and not have it overloaded. And then this is going to build the cells and portals for that mesh. So in here, let's do graph. Now I'm going to pull up my source material if I can find it. Here we go. Is it Hexmod? Is this the one I want? This will do. Need to do a tiny bit of maths here. If our chunk had a radius of 0, then we'd have a single hex in it. And we would expect the number of outgoing edges to be 6. Easy enough. If our radius were 1, then all of a sudden our chunk would include these 6 surrounding hexes. So the question is how many... we'd then expect this bigger hex circle to be in the next chunks. Now, I need to work out what this pattern is because I need to know exactly how many outgoing edges, like non-connected edges, I'm expecting to see. Oh, sorry, non-connected portals. Now, I believe that this sequence is called centered hexagonal number, I think. Will tell me the actual... Yeah, this looks right. We can ignore this one because we never have an empty chunk. The first one has 6. Then we have 12, not 19. What am I doing? Don't give me that. Oh, stop it. Okay. Next one has 12. Next one has 18. So what we actually care about the difference between hexagonal numbers. So we need a way of getting this. This is going to be equal to this for n equals 1 minus n equals 0. So I'm going to just open I'd normally do this on paper, but let's get this in here. This is the formula we want. 3n squared minus 3n plus 1. 3n squared minus 3n plus 1. Now, I then want to subtract from that 3n minus 1 squared. So this is just the previous number. Minus 3n minus 1 plus 1. I want to subtract this from the original thing. Now, I'm hoping that for n equals 1, I want a value of 6, if this is correct. So let's see. We get 3n squared is just is obviously just 1 in this case. That's 3 minus 3 is 0 plus 1. All right. So this is going to be 1 minus this expression, which is n squared is 0, n is 0 plus 1. So we get 1 minus 1 equals 0. All right, what about n equals 2? I might just be off by 1. This is going to be n squared is 4, so this is 12 minus 6 plus 1. That whole thing comes out to 7. This looks promising. Minus, and we've already done the previous term. We knew that it was 1. Okay. So I've got an out by 1. Probably just in the way I've defined something or the way these guys are defining something for the 0th number or the first number. But I happen to know that this is going to be 3n squared plus, that is a plus 3n plus 1. Exercise for the reader. This is exactly identical to 3 of n plus 1 squared minus 3 n plus 1 plus 1. I am 99% sure that this is exactly the same as that. I'm not going to do it out by longhand. I happen to have done this same calculation about 15 times for this project so far. So I want that minus 3n squared n squared minus 3n plus 1. Now, what is the difference between those? This cancels out. This cancels out. This minus that is just 6n. The 1 and the 1 cancel out. Is that right? And it is. And I could have just seen that by looking at this sequence, that it is really just 6 times n. Okay. So my radius is 1. If my radius is 1, the number of unconnected edges should be 12. So this needs to be 3n plus 1. Excellent. If my radius were 2, I'd expect 18 disconnected, 6, n plus 1. Okay, I'm satisfied that I know how many disconnected edges there are. There should be 3 times radius plus 1 edges that are not connected. Graph dot edges dot filter. So we're just going to find any edges that don't have a 2. Sorry, not edges. This is meant to be portals. Stop it. Stop it. Stop it. Graph returns a graph chunk. This is meant to be cells. This is meant to be portals. Excellent. So I then filter portal goes to portal.2, just not portal.2. So if we don't define the 2, this can return an undefined. Excellent. And then I'm just going to count these. Const unlinked portals. Get num unlinked portals. And then we expect the number of unlinked portals to equal 3 times coordinate system dot radius plus 1. And I know I've got a typo in there. That is meant to be a 3. Okay. Run the test. That was a whole lot of work for something that I'm 99% sure works as long as my test is correct. Let's fix my includes. Rerun the test. I don't rerun all the tests. Graph. Paths controller. Something is of the wrong type. Oh, I think I know what this is. So that is of the correct type. That's returning a graph chunk. But if I come back into my test, when I'm mocking things out, I think I've got the wrong types on things. Here we go. This should be cells. Shift F6, cells. This should be portals. Got no reference to vertices anymore. No, that should be portals. I know it's only a comment, but let's be consistent. Okay. Try running this test again. And it's still failing. All right, I've obviously got the text vertices colon cell existing somewhere. I've got it all over the place. So anywhere I see this, it needs to be a graph chunk. This needs to be cells. This should be a cell. All right, let's find another one. Graph chunk. Got a compile error somewhere. And that's because this needs to be a graph chunk. Okay. I think that's all good. Coming back to the test. Rerun just this test for now. Okay, that passes. I'll rerun all of these tests, make sure I haven't broken anything else. I should have run my tests after doing the refactor, because a bunch of those failures were to do with the refactor. There we go. So what I thought I saw, where's my, here it is. What I thought I saw over in here, with the graph build being suspicious, I'd say that I was messing around with the chunk radius at some point to help debug something. And so I actually saw very small chunks or something like that. And I suspected something was wrong, but it looks fine. So, quick demo time, just for my own satisfaction. In theory, I know I say that a lot, um, it should now be possible to spin up the troll and he should run towards me. It still won't make a huge amount of sense because of the way I'm generating the path through those portals. He's already running. He will still take a little bit of a staggering path towards me, I expect. Sorry, I'm going to increase my frequency up to 10 hertz. Oh, no, not the hex radius. Terrain hex radius is meant to be 8. I have something silly there. I will look at that later. Stop that. Restart it. Yeah, he'll still take a staggering path, because I'm just taking the midpoints of those portals. Come in here, connect him. Turn off my breakpoints. Let's just turn them all off. I have no idea what state anything is in. Okay. I'll just delete all my entities, recreate the troll, and then bring the player back in. Hey, that's not good. All right, something is definitely wrong there. And now he can't move. All right. What on earth is he doing? Ah. I have a feeling the troll is getting updated multiple times at once. So, you can see he kind of jitters. I think that, oh, now he's not jittering. Well, now he's also not running. Hey, he's really not meant to do that. Okay. Something is broken. Now, I may well ignore it for now and just make a note of it. I'll just run him again. I'll turn down my frequency to 3 hertz, just in case I do have an issue with the A star taking too long and I'm not synchronizing my ticks and things yet. So if that's the case, then slowing down the frequency should correct that. All right, let's try it. He's still coming down too low. And he also stops once he's gotten to me. Oh, no, that's... All right, I know exactly what that is. And I think I know why we keep on falling down through the ground as well. So the issue here is he can only operate within a single chunk. So once he gets outside the origin chunk, things are breaking. So I don't know why he's falling through the ground. I had fixed a bunch of issues relating to that. So Oh, here we go. We've got him moving a little bit. But yeah, the issue here is that we're only loading a single chunk at a time. So it's time for me to fix that. Again, the question of why he's falling through the ground, I can't answer that yet, but that has been an ongoing issue for me. All right. So I do have a bunch of comments around the place as I've identified how I'm going to implement this. I think I can get rid of this code now. I don't think I'm going to need this because we're not really dealing with the chunk height map data itself. Hello, MHSTRE, and yes, I'm doing very well. We have A star working within a chunk now. So now I'm working on getting it to load additional chunks into the pathfinding algorithm and be able to do searches between chunks. And that will mean that the troll can properly chase us. Oh, right. Chunks are a little bit like Minecraft, except mine are hexagonal. Yeah, so this is kind of what my chunks look like. So these are my, where Minecraft uses square voxels from the top down, mine are hexagonal, and my chunks themselves are also hexagonal. Okay. So at the moment, the very first thing we do is we generate the mesh for the origin chunk. We never do the graph, we never run the graph builder on any chunks other than the origin chunk. I need to make it so that it does more than that. Now, that means that this graph is probably of the wrong type, because this is just going to be a graph chunk, I believe. And that compiles, so yes, that is a graph chunk. Inside my graph builder, this is the graph builder just here, it goes through each vertex in the, well, it goes through each triangle, sorry, in the mesh and converts each one to a vertex. It creates 3 outgoing edges. If the triangle we're going to is already loaded, so if it's already in our current chunk, then we generate an edge like this. So we connect it up to the other vertex. That's all fine. If it looks like it's in another chunk, then I just create a new portal, and I don't give it a 2. Now, what I need to do is I need to store enough information. Where am I from? I'm from Sydney, Australia. What I need to do here is store enough additional information that we can reconstruct these portals as other chunks are loaded. Now, I've got this dummy type here. I've got this comment saying to work out what information I need to store. I reckon I know exactly what I need to store, and it is why I have this page loaded. I've mentioned in a lot of my episodes a third kind of coordinate called the hex mod coordinate, or just M for short, M for mod. And it is a pattern of single integers that is unique across a fixed size hexagonal tiling. So in my case, a chunk. So if this is a chunk, there's this numerical system that counts up. It goes from the center, it goes 0, and it goes 1, 2, 3. Then it jumps to this other spot over here and goes 4, 5, 6, 7, then down to here, 8, 9, 10, 11, 12, 13, and now you can see it kind of fills in these stripes across the entire hex, the entire chunk. Now, it seems kind of pointless at first until you realize that when you've got a chunk like this one, you go 0, 1, 2, 3, 4 is down here, or you can actually just continue in a line. It's actually quite cool. If you want to head in another direction, like say we're going to head down to the southeast here, you can actually just take the hex mod of the first tile you're going to move to. In this case, it's 10, and you can just keep incrementing by 10. So you go 0, 10, 20, 30, and then this would be 40, but you have to take the modulo, however many tiles there are, and that will actually bring your deck back down to, what is it? I think it's 3. They must have 37 tiles. Yep, 0 comes up to 36. So 40 modulo 37 gives you a 3. That gives you the next tile number. So how does this help us? Well, I'm trying to do these stitchings between these graphs. When I'm coming out from a cell, so these are my cells, I need to know, they're almost my cells, sorry. My cells are actually the triangles that make up this hexagon. I need to know, well, I can know which hex mod we're coming from. If I store which hex mod we're going to, then what that lets me do is as I load this next chunk, I can just find the correct cell because I can find a cell with the correct hex mod number that has an edge going back to the source hex mod number. Now, if that doesn't make sense, it's not the end of the world. I am going to, it will hopefully make a bit more sense as I implement this. It is entirely possible that I am not understanding it myself and then I'm going to run into problems. So I don't want to go to too much effort describing the ins and outs of it. But my suggestion here is that to store a linkage between two chunks, all I need is a from hex mod, which is going to be a number, and a to hex mod. Now, I'm even going to just make this an interface because this is such a small, simple type. Just going to go from hex mod to hex mod. It's going to be a number. I'm just going to tell IntelliJ that this is actually spelt correctly. So given those two numbers, when we are storing our 2, we could store a link to a cell, or we could store a link to an interchunk vertex reference, or undefined. This won't happen currently because I do have a fully connected graph, but in time, you will get these disconnected edges happening where there are cliffs and things like that. Okay. Now, this is going to complicate my code a bit because I now need to handle the case separately. We can get rid of this. That's a better way of doing it, the way I had already implemented it. So we are either going to define a cell or we are going to store an interchunk reference. Now, when I build the graph, I need to be a bit smarter down here. I can't just create a disconnected portal. And apologies for those who are new here, I am still using the term edge and portal interchangeably. I'm trying to call these portals just to make it a bit clearer if I'm talking about graph linkages in graphs or the actual edges in a mesh. Okay. So when I create one of these, what do we actually do? We try finding something sharing, some other cell sharing corners with this cell. Because in a, I'll just bring up Red Blob Games. if this is my voxel, and this is a face within the mesh, you imagine another triangle over in here, it will share two mesh vertices with this triangle. And then over here, you will have another triangle here. It will share two points. So it's true that if you can find this shouldn't be vertex index, should it? Vertices. Sorry, I'm still fixing these up as I go. These are meant to be cells. These are not edges, these are portals. So when it tries to find another cell within our chunk, sharing corners with this one, great. It finds an adjacent one within the same chunk and it can hook it up as a normal portal. But otherwise, what I want to do is make a portal that is linked to an external chunk. Okay, let's do this. I need it to be... Can I run some code in here? No. Okay. I really need to simplify this code because this is going to start confusing me. Create external linkage. Now this is going to return a portal. We need to know the vertex it's coming from. No, vertex is wrong here, isn't it? This should be... where's that defined? Vertex index should not be vertex index. That should be cell index. And vertex in here should be cell. Okay. To create an external linkage, we need to know the from cell. It will return a portal. So I'm trying to replace this here. Okay. Now, I'm not sure how to get the direction, so I'm going to have to think about that. This might not be as easy as I was hoping it was going to be. New cell is going to be a new cell from cell in not cell, this is a portal. Turn the new portal. Okay, so this is still just doing exactly what the old code was doing. But we get to pass in here, create external linkage. We get the same here, and we get the same here. Now, in here, I want to replace this code with a function that is going to... a function that's going to create an internal linkage. Oh, what did I just press? There we go. All right, I'm just going to cut that code out. Create internal linkage. Const create internal linkage. Whatever it is, it's going to return a portal, and it is that code Okay, we need a 2 cell, which is a cell. That should be 2 cell. We need the corners. Which I think is just going to be number. And that's always just going to be 0 and 1. Okay. Nope, this is meant to be from cell. Okay. Oops, what did I just press? Ah, keep on pressing F1 for help. This kind of makes sense. So to create an internal linkage, we need to know which cell we're coming from, which cell we're going to, and the corners they have in common, the corner indices that are in common. So when we come down here, this is just going to map the to vertex, is going to map to create an internal linkage, passing it the cell, the to cell. So this is the cell we're considering, this is the cell we're linking up to, and then we need to pass it the corners. Oh, well, this one's easy. We just pass it corners directly. It doesn't like that because it's the wrong type. All right, I have to repackage them. Corners 0, comma, corners 1. Okay. This is at least simplifying the code a bit. I've still got this horrible conditional on here, which I'll worry about in a moment. No, I've got something wrong in here. Let's take a look at this one. These question marks are applying to the wrong thing. This is why I shouldn't write really, really, really ugly code. Okay, so in here, it's trying to find cases where I can't even tell what this is doing. It tries to find any vertices sharing these two corners. Okay. It finds ones that are not equal to the cell we're currently considering, because we don't want to create edges. We don't want to create portals back from one cell back into itself. That would make absolutely no sense. So we expect at most one element out of here, but we could get 0 if we're on the edge of a chunk. It then maps that onto an internal linkage. We could get either 0 or 1 of these, but it's going to be in a list. Okay, so that is why I do that. So here we go. We go map that to the internal linkage. At this point, we could have 0 or 1 of them. Here we go. And if we don't get a 0th element, then we just create an external linkage. Okay. Let's move on to the next one then. Filter, map, create internal linkage, except this time our corners are 0 and 2. So here we pass it 0 and 2. And then the third one, we pass at corners 1 and 2. What have I done? In here, we pass at corners 1 and 2. All right. I'm still not creating these external linkages properly. And the issue I have is, how do I know which direction I'm heading in? I wish I had a more blown up version of this, but this'll, oh, can I just, nope, I can't just zoom in. Oh, what have I done? So if I'm down here, I need to be able to distinguish between heading in the hex mod -1 direction, the hex mod plus, what's that, plus 10 direction, or the hex mod plus 11 direction, I think that one is. So how do I work that out? We know our own hex mod. Let's just put that code in, because I store that on the cell itself. Well, I store the coordinate on the cell. So const from hex mod is going to be equal to the from cell dot, where's location? I had a location on here. Coordinate. I just don't expose it. Public get, well, let's do a hex mod, which is going to return a number. Return this dot underscore coord dot m dot qr dot m. Yes. So that is just pulling the hex mod representation off the individual voxel that this triangle is part of. If we come back, create external linkage, and in here we can just do dot hex mod. Beautiful. Okay. Const to hex mod. And this is where things get tricky. How do I calculate this? I just need to reason this through for a bit. I can think of some horrible geometrical ways to work it out. That might just have to do me for now. Because if I can find the x, z coordinate, so the planar coordinate, for a point within the triangle, within the hexagon that I want, then that will give me the hex mod. For a given cell, I know the center of this cell. I know the two coordinates that I'm trying to find an edge for. So what I could do, this is really, really dodgy, is I could find the midpoint of that portal, that gateway. I I could take the difference between this centroid here and that midpoint, and then I could just double it. Put me over in here, which will tell me the hex mod that I'm after. All right, this is so dodgy, but I am going to do it. So we have the corner indices. I need to go further. I need to know the actual corner coordinates as well. I don't have these corners yet, but I am going to need them. Let's do corner locations, which is going to be a vector 3, vector 3. This is so horrible. Okay, so I've got our from hex mod. We take our corner locations, we add them together, and then we divide them by 2. So that gives us the midpoint of our corners. Const, let's call this one gateway midpoint. Const let's say direction is equal to the gateway midpoint minus the from cells center. So this gives us a vector from the center of this current cell to the center of the gateway we're about to pass through. So the target center is then going to be equal to our from cell. I'm actually going to multiply this by 2. The from cell center plus the direction. Now that should put us smack bang in the middle of the adjacent cell in some other chunk. So now I can do the target axial coordinate is going to be axial coordinate dot from vector. We give it the target center. So that gives us the actual voxel coordinates of where we are going. And so the 2 hex mod, I think, is just the target axial dot n. Wow, that is really hacky. So we have our 2 hex mods. So we can now just say new portal dot, I need to give it a linkage. Public. Get. No, I don't only want to, oh yeah, I'll need a setter and a getter. Linkage, into chunk vertex reference. And does this let me do a getter? No. I think I have to allow undefined on there. Yeah, there we go. All right. Coming back to where I was editing, new portal dot linkage. This has a from hex mod and a to hex mod. All right. Cool. Now, what I don't know that I do need to know is I need to know which chunk this is part of so that I can actually load the correct chunk. This file is getting ridiculously big. Into chunk reference. So we've got a from hex mod, a to hex mod, and let's put a to chunk in here as well, which is going to be a chunk coordinate. That should have caused a bunch of compile errors. Yep, here we go. Let's put a to chunk on here and to chunk. Which I'm actually going to pull out of the target axial divide by chunk. So this axial coordinate here is actually in sort of a global coordinate system. It's the just the coordinates of the hexagonal tile that we're in, ignoring any chunking or anything like that. So this could get quite big. By dividing it by chunk, that actually returns two parameters. The first one being a chunk coordinate. Is that valid? That's apparently not valid. Syntax, that's right. The second parameter would be its axial coordinate within the chunk that we've just returned. Kind of like a divide by with remainder operation, this divide by chunk. I'm just going to call that a global axial. The to chunk is that, and then we pass it the to chunk. Okay. So at this point, we should know what the hex mod we're coming from, the hex mod we're going to, and the chunk that needs to get loaded in order to traverse this linkage. Excellent. These need to know their coordinates. Before I do that, I am going to factor this code one step further, because these are all identical except for these indices. So let's go corner pairs. Pairs is going to be a list of, it's just 0, 1, 0, 2, and 1, 2. And then we're going to iterate over these. Const portals is going to be corner pairs dot map. We are going to take corner index A, corner index B. And then all we do in here is return that. I might simplify to get rid of some of these question marks in a second. So portals should now effectively be E1, E2, E3. Oh, once I pass these through. That needs to be corner index A, corner index B. Okay. Indices is going to be equal to corners. Let's just pull these out. Corners index A, corner. Nope, that needs to be corners. Corner index A. Sorry, I'm not doing a very good job of commentating what I'm doing at the moment, which is a consequence of me not being entirely sure what I'm doing. But in here, I can pass through corner indices. Oops, corner indices. And in here, I can also say corner vectors is going to be vector vertices. No, not vertices. Yeah, do I have a vertices? I renamed too many things in here. I need the mesh vertices. Okay. This needs to be mesh.vertices corner indices 0. I can go further. We just go corner indices.map to mesh. Oh, I goes to mesh.vertices. Oh, okay. So what I've done so far is I have mapped the given these pairs, which is just all the combinations of corners on this cell, we get the indices that are needed by this function. It still doesn't like this. Why not? Not type number is not assignable to number. That's fine. That can just be a number. There we go. I also have the list of the pair of vectors, vector 3. Now, it doesn't like that. That's because of this map. It's a bit annoying. I'm going to have to do this out in full. So that becomes mesh vertices corner indices 0. And then exactly the same thing. Here we go. All of that into there. Still not happy? Why not? Dot. Vertices. Oh, that is a mesh vertex. Yep. All right. I've got some conversion function I can use here. Convert mesh vertex to that. Yeah, almost there. Do exactly the same thing. Beautiful. So create external linkage. Get rid of that, give myself a bit more space. This needs the from cell, and it needs the corner locations. Well, I've got the corner locations. That's the corner vectors, which I will just rename to corner locations. There we go. So for each cell, we should now have 3 portals. They are either an internal portal, in which case they just point to another cell, or they're external ones, in which case they point to some other external linkage, which will allow us to load it in a moment. This code is still looking nasty, so let's get this cleaned up. That links to there. Then we've got that, and then that. Const internal linkages is going to be equal to that. That shouldn't be a void. Yep, that's fine. That should actually be just that. And then we go if internal linkages dot length, then return internal linkages 0. Just get the first one. It'll never be more than 1. And then in here, we can do an else. Return that. Here we go. That's looking simpler again. Internal cells is going to be equal to that. I'm actually going to say if internal cells dot length is greater than that, then return that. Internal cells 0. Okay, this is looking a bit prettier. That code was really annoying me. Beautiful. Much better. So I now have portals instead of these horrible 3 massive repeated bits of code that I had before. Cell.portals is going to be equal to portals. It doesn't like that because it's expecting exactly three portals. I'm just going to have to bite the bullet and get that factored out. I wanted to keep that as that existing type, but it's just not worth the effort. And I have one more place to change that. It's here. You have to ask IntelliJ to do this one for me. We're going from that to portal that. Oh, we've only got one instance of it anyway. There we go. Okay. That code is looking a lot nicer. So next, I need to modify the A star to make it so that it can load other chunks through those linkages. To do that, where's the build? Graph builder. So here it is. I need to give it an index of graph chunks, so that given a chunk coordinate, it can look up the graph for that coordinate. Class graph chunk index. This is going to need a method which is get graph chunk given a chunk coordinate. And it is going to return a graph chunk. Internally, it's going to have an index, which is of type going to map from a number to another index being number, which itself is then going to map to, oops, wrong bracket there, number, that itself is going to map to a graph chunk. Going to start with an empty index that we do need to initialize that. Then in here, we need to check whether or not the item is in the index already. So let's start with if the chunk coordinates u value is not in the index, then I will, wrong brackets, there we go. I will put it in. Just an empty one. And then const u index, oh, let's call it, this is now a v index, is going to be equal to this dot underscore index dot u, just like that, I think. Chunk coordinate dot u. Then we check if the v is in the v index. If it's not, then we need to add it. V index v chunk coordinate dot v is going to be equal to, I'll need to think about what that is. And then we just return that. Turn that, because we now know that that is going to be the correct chunk. So if the chunk already exists, if it's already had its graph built, then we will just come straight through to here, then straight through to here, because it'll fail in here. If anything doesn't exist, it'll create it as we go. And in here, I need to build the graph. So up in here, private underscore builder. This needs to be a function that, given a chunk coordinate, just do it in full, chunk coordinate, it will return a graph chunk. I'll pass that through to the constructor. Create getter setter, add it to the, I don't seem to be able to add that to the constructor automatically. That's a bit annoying. So let's go, builder is going to be one of those. And in here, this dot underscore builder is going to be equal to builder. So now, if the graph chunk is not currently in our index, then we can actually just ask it to get built. This dot builder, and pass it the chunk coordinate. Okay. I'm going to replace this function, this code just here, because this is currently just a graph chunk. We need this to be a graph chunk index. But I already can see that I need to pass a second parameter in here, which is going to be the origin chunk. Just something to get the whole thing bootstrapped. We don't need to actually store that, but what I can do is I can put in here the chunk coordinate dot, no, origin chunk, sorry, origin chunk dot, oi, dot u, which is going to map to, oh, that needs to be in square brackets. Going to map to origin chunk dot v, again in square brackets. And that is going to map to, we need to build the chunk. So builder origin chunk. There we go. So that will initialize the index with a single graph chunk. Now I can come back to here, and our graph is now going to be equal to const graph chunk index is a new graph chunk index, passing it a builder. Okay. So the builder needs to take a chunk coordinate. And then that needs to return this dot graph builder or get mesh of the chunk coordinate. That is not happy. I'll sort that out in a second. But we also need to pass it the origin chunk. And that made the whole thing pretty happy. Excellent. So we've told the index how to build a graph given a chunk coordinate. It has to get the mesh for the chunk coordinate, and then it needs to generate the actual graph. Shortest path currently takes a graph chunk. This needs to take a graph chunk index. Likewise, this has to take a graph chunk index. And then in here, we can get a bit smarter. I'm going to take a quick step back. I was wrong about something here, which is I should not be initializing this at all. And I'll show you why. The reason I shouldn't be initializing it is that I will be initializing it as part of my search. I'd be looking up the origin chunk and the destination chunk at the start of the search. So this can remain as just an empty index. Then when I start the search, the first thing I do is I try to find, not a vertex, it should be find a cell. Find a cell near a point. This needs to make sure that we have the chunk loaded. So const graph chunk is going to be equal to graph dot. I don't think I have a current get method, but I'll put that on in a second. We need to know which chunk we are looking in. This is easy. Const coordinate is going to be equal to coordinate from vector point. And then in here, I will just confirm that this does divide by chunks. Yes, excellent. In here, we just pass it the coordinate .uv, which is actually the chunk component of the coordinate. I need to define this method. And this is going to return a graph chunk. No, this is wrong. Graph here is meant to be a graph chunk index. Then I can put the chunk coordinate on there, make this public. It returns, sorry, my fingers are all over the place here. One of the problems with streaming I find is I can't see my fingers. I often look at my fingers. I can't see my fingers because I've got a microphone in front of me. This is going to return a graph chunk. Or it could return undefined, I suppose. Oh, I already had this method. Get graph chunk. Sorry about that. Get graph chunk. Nice. Then this will go and look through the cells within that graph chunk and try and find the best cell for the origin point or the destination point, whatever was passed through. So coming back to where this is called, this is where the graph actually gets initialized. So we load the origin chunk, we load the destination chunk, and we pull out their cells. There's a big refactor that's been happening today, which is why all these vertex references are becoming cell references. Cell. Okay. So given we take the origin, we take the destination, this code here, I don't believe can actually happen anymore because this, it can. So we can return a null from here. No worries. So if we can't find them for some reason, then it will just throw an error. That really shouldn't happen unless the world had no chunks in it, I think is the only way that could possibly happen. So we add an item onto the queue. This is a root state. It has no parent. We've got the origin cell. So there's the cell that we're searching from. The cost that we've spent so far, obviously 0. We estimate the cost by just taking the direct straight line distance from the origin to the destination. And followed edge, I can't remember what that actually means. I'm sure that I'll understand that as I go through here. While we have things to process, pull an item off the queue. If it is the destination, then we have finished our search. We got there, and then it'll go and reconstruct the path. Otherwise, it goes through each of the portals. Then it says, I'm going to get rid of that. I'm going to move this down into here. There we go. What it says here is that the 2 vertex is wherever it's going to. Now, this could be undefined in the case that we have a cell right on the edge of a chunk. And so we want to say in here, else const linkage, external linkage, is going to be the edge dot linkage. So else if external linkage, so do we have an external linkage? Then we need to cause it to load the edge from the graph. Load that chunk from the terrain service. So we have our external linkage. We have a 2 chunk, which is a coordinate. We need to go external graph chunk. External graph chunk is going to be equal to our graph, get the graph chunk for where we're linking to. I really hope this works. So that gives us the chunk we're loading. We then need to find the cell that we're connecting to. Now, to do that, we need to find all of the cells, external graph chunk dot cells, and we need to find other cells who have an edge pointing back to this cell. All right. To do that, we need to look at the portals, and we need to filter them for, let's just be a bit clearer here. That is other cell. This is portal, goes to portal dot linkage. Oops. So it has to have a linkage, and it has to link back to our coordinate. Okay, so portal dot linkage dot where does that, do I expose it? It's an interchunk reference. It's 2hexmod, okay. 2hexmod is equal to this hexmod. What's this hexmod? This hexmod is state.cell.hexmod. Nice. Okay. That's not enough though. Just because something is pointing to this one, we also need to find a portal, a portal whose linkage from hexmod is equal to the external linkage dot to hexmod. Okay. Portal implicitly has any type. No, we want that to be a portal. Oh no, that will resolve itself when I get my names right. Now I will be finishing up the stream fairly soon. It's just starting to get a bit long, and I will need a food break pretty soon. Okay, so portal, we check whether or not it has a linkage. We check that the hexmod that other linkage is coming from. Let's just rename that to other portal. Check that other linkage is coming from the hexmod that we are trying to link to, and that the other hexmod is trying to link to us. Const matching portals is going to be equal to that. Okay, so we've got our list of matching portals. We want to find all of the cells in this search where we have a matching portal. So if we find a cell with a matching portal, then hooray, we've found our linkage. So in here, we want to say if external, no, I need to put, introduce a local variable and go matching cells. So if the matching cells are greater than 0, then we're just going to take the first one. This is one of those cases where we really should never see multiple matches, just the way the geometry of my coordinate system works. I'll even put a warning in here. If matching cells dot length is greater than 1, then log.warn found too many external linkage candidates. What did I just do? There we are. So I've got our 2-cell. So I can just probably repeat code very similar to this. This needs to be 2-cell, although I notice up in here this should also be called 2-cell, just part of my refactor to rename, to disambiguate between graph and mesh vertices. Expended cost, this is a bit funny. We don't store the cost on external linkages. So I'm going to have to calculate the cost. But that should be pretty easy. That's just the expended cost from the state plus the cost of traversing this new virtual linkage. And that is just the 2-cell dot center minus our current cell's location, which is what state.cell.center dot magnitude. All right. I would say that looks good. Oh yes, I remember what followed edge is now. We use it to reconstruct the path so that we know as we traverse the states that come back, we know exactly how to get back to this state. All right. I think that looks pretty good. I've got one question in my mind, which is the default graph builder, which is what's the default graph builder? Graph builder, oops, is this method here. Does this set the costs correctly? I don't remember writing that code. It's the internal linkage. Yeah, I don't think I actually calculate that. That's a bit silly. I am slightly surprised that this code worked at all. Okay, there's the external linkages in here. When we do the internal linkage, in fact, I think we can calculate the cost in either of these cases. So we set that. I can also set the portal.cost, which needs to be the 2-cell dot center minus from cell dot center dot magnitude. It doesn't like that because I don't have a setter on it. Do I ever set that? Cost. It's initialized to infinity. I do set it. I see. Yeah, I'm not a huge fan of this. Yeah, okay. I think this is working, but I'm not allowed to set portal costs. They get set when I set the 2. My current code ignores that for external linkages and computes it on the fly. So I think this will this should work. Does the code run? It's the next step. Now, as I said, I will be finishing up soon for this stream. So I'll probably just see if this works, see if there's anything obvious I can fix if it doesn't run. And then I will just try demoing it and see if it works at all. Where are we at? This appears to be running. Let's hit the endpoint manually. Okay, that kind of worked. That was a search within a chunk. So now let's give it, oh no, I created a troll. Hang on. Let's hit the right endpoint. No, that crashed. That's more like what I was expecting. So it doesn't like in. I thought that was valid TypeScript. Cannot search for 0 in undefined. Ah, okay. Path controller line 391. V index. Here we go. This is meant to be chunk coordinate.u. All right. Did that just rerun the service? Hopefully. Yeah, I think that reran the service. Rerun it. Okay, and we got a path back. Is it a sensible path? Not overly. It just had the origin and the destination. It was a pretty small search though. So let's just change this X to 10. Run that. We get a slightly longer path back. That's good. What if we give it a crazy X, like 1,000, so that it has to definitely load lots and lots of chunks? And we appear to be in an infinite loop, I'm guessing here. I hope this isn't performance. Yep, I'd say that we are in a loop here. So I won't debug this right now. I will do that off stream, and then on stream tomorrow, I can probably start working on serializing these searches and getting the troll behaving a bit more sensibly. So he doesn't need to rerun the search every single tick, which is what he's doing at the moment. So thank you everyone for joining me. It's a fairly long one today and mostly just boring debugging. So I think my server just crashed because it ran out of memory. So yes, thank you. And I look forward to seeing everyone again tomorrow if you're able to make it. Catch you around. Thank you.